All right, guys, we are about to start what I consider to be probably the most important, or one of the most important topics that we're going to be covering all year in Algebra 2, and that's factoring. Okay, so we need a really strong foundation of factoring in order to understand things that we're going to be further doing later on down the line in different chapters with factoring, but starting with the basics. So these first three problems, so we're going to solve each of the following quadratics by factoring. But these first three, it says GCF only. So all you have to do to factor the first three problems is just simply take out a GCF. So when you're looking for a GCF, if you scan through problem number one, it's just basically looking at, so we know GCF stands for greatest common factor, but you want to look at and see what can I divide the whole entire problem by. So if you look between 6x squared plus 9x, you could definitely divide out a 3, but you can also divide an x out from each term. Okay, so whenever you determine what the GCF is, again, looking at the numbers between 6 and 9, you could divide those both by 3. Between x squared and x, you could take out an x. So 3x would be my GCF. So now you just want to divide each term by the GCF of 3x. And then what you have left over is going to be inside of parentheses. So if you divide out a 3x from both terms, what you're going to have left over would be 2x plus 3. Okay, and believe it or not, you are done factoring. You took out your GCF, you cannot factor anymore, so now you have to actually solve it. So how you solve it is you want to set each factored piece equal to 0, and then you just want to solve each piece. So we're solving for two answers ultimately in the end. So there's two possibilities for our solution. Divide both sides by 3, but x would still be 0 as one solution. Second one, subtract the 3, so you have 2x equals negative 3, and then divide both sides by 2. So you're looking at negative 3 over 2 as your second solution. Okay, so keep in mind too that we're talking about a parabola here. So anytime you see x squared, a quadratic function, technically this would graph out to be a parabola. And whereas crossing over the x-axis, there are x-intercepts would be at 0 and then also at negative 1.5. So negative 3 over 2 is just the same thing as negative 1.5. Okay, so look at problem number 2. Same idea, take out a GCF, which would be a 2x in this case. So you take out a 2x. And then what do you have left over when you divide each term by 2x? You would have x minus 4 left over. All right, so again, we're done factoring. So set each piece equal to 0. And now we just simply want to solve. So dividing both sides by 2, you get x is 0 still as one solution. Add 4 to both sides, x is positive 4. So this parabola will be crossing over the x-axis at both 0 and then also at positive 4. Okay, and then number 3, the last one again, GCF would just simply be 4x. So now take out 4x from both terms. You'd have x plus 6 left over. And now solving it, set 4x equal to 0, set x plus 6 equal to 0. Our two solutions, we get x is 0 and x is negative 6. Okay, but that's it. Two answers for each of them. Again, parabola's crossing over at both 0 and then at negative 6. Okay, I just want to mention one thing too when it comes to factoring. Factoring is kind of like the reverse of multiplication. Okay, you're undoing the multiplication. So whatever you take out, if you're taking out a GCF, so like problem number 3, if we go back to it, if you redistribute that GCF, if I redistribute 4x to both terms, you'll be back to where you just started with the 4x squared plus 24x. So like I said, I'm basically undoing the multiplication. Okay, if I take it out, and then if I remultiply it back together again, you'll just be back to where you just started. Okay, so keep that in mind when we go through even these next problems. So these next three are all very similar. They're called, and it's already abbreviated for you, DOS. This stands for difference of squares. So these three, you want to factor them as a difference of squares. So let me just kind of break down the terminology real quick. The word difference means you're subtracting. So if you notice in all three of these problems, there's a minus sign, you're subtracting in all three of them. Okay, and what you're subtracting are squares. So what are squares? I'm talking about perfect squares. So like x squared is a perfect square, 100 is a perfect square. X squared is a perfect square, 49 is a perfect square. 4x squared is a perfect square, so is 81. So how a difference of squares factors every single time, again, these are relatively simple. But if you take the square root, so for number 4, if I take the square root of x squared, that'd be x. If I take the square root of 100, that'd be 10. So how it factors is just going to be x minus 10 and x plus 10. So it's essentially the same binomial twice, but one has a plus sign, one has a minus sign. Okay, and that's it. You're done factoring at that point. So again, as I kind of mentioned those previous three problems, if you remultiply these two back together again, I will get back what I just started with, and that's x squared minus 100. So if I FOIL these two back together, if I start this off, you don't have to do this either on your paper, but if I remultiply, I get x squared plus 10x minus 10x. So guess what happens there? They cancel. Negative 10 times positive 10, that's negative 100. And again, you're left with x squared minus 100. That's exactly what we just started with. So again, you want to think about factoring as just the reverse FOIL. Okay, so if you're not confident in your factoring, if you're not sure, if you're like, oh, does it really factor that way? I don't really know if that's correct or not. If you're not confident with it, you can just FOIL the two back together again, and you should get back exactly what you started with. Okay, so we got it factored, so now we just need to solve it. So I set x minus 10 equal to 0. I set x plus 10 equal to 0. Again, you get two answers. You get positive 10, then you also get negative 10. Okay, or if you want, you could write your answer like this as well, positive negative 10. So instead of writing them out separately, you could just combine them to be plus and minus 10. So number 5, similar idea. Square root of x squared is x. Square root of 49 is 7. So it factors into x minus 7, x plus 7. And now solving once again, set them equal to 0. There are two solutions come out to be essentially the same answer, but one's positive and one would be negative. Or again, if you want, you could just say positive negative 7 together. Okay, and the last one in this row, take the square root of each term. So square root of 4x squared would be a 2x. Square root of 81 would be 9. So this would be 2x minus 9, 2x plus 9. And now we're ready to solve. So set each one equal to 0, 2x minus 9 equal to 0. Set 2x plus 9 equal to 0. Solving, you'd have to add the 9 and then divide by 2. So we get positive 9 over 2. Then we'd have to subtract the 9, then divide by 2. So we get negative 9 over 2. So there's our two solutions. Okay, so difference of squares. Again, these first 6 problems, to me at least, I think they're relatively easy. They're something that you should recognize right away. Okay, so hopefully this is kind of coming back to you guys a little bit. But now in our next section, so I just usually call these basic trinomials, just regular old trinomials. Okay, and again, these should definitely look familiar to you. So for problem number 7, here's how I kind of pose this question. All right, if you wanted to factor this and solve it, first thing you're trying to find, I usually make this little T-chart over here. What you're trying to find is you want to find two numbers that multiply to be your C term, which is 35. And those same two numbers that multiply to be 35 have to add to be your B term, which is positive 12. Okay, so again, just think of numbers that multiply to be 35. Think of that first. So what do we know that multiplies to be 35? There's 1 times 35, and there's 5 times 7, and that's it. Okay, so if I add these two numbers together, am I going to get 12? Well, obviously 1 and 35 is too big, so it can't be that. So it's got to be 5 and 7. So if you think about it, 5 plus 7, is that 12? Checks out. It's all good. Okay, so how is this thing going to factor now? Well, it's going to factor into two binomials. One of them is going to be x plus 5. Other one's going to be x plus 7. Because both 5 and 7 are positive, that's why it's going to be x plus 5 and then x plus 7. It doesn't matter the order that you write these in. So even if you wrote x plus 7 first and then x plus 5, doesn't matter as long as you just have both of them. Okay, because you still get to the same answer in the end no matter what. If you set x plus 7 equal to 0 and then x plus 5 equal to 0, our two solutions would be negative 7 and then negative 5. And there you go. Okay, so same thing for number 8. I'm trying to find two numbers that multiply to be 36, and those same two numbers have to add to be a negative 13. So we got positive 36, but negative 13. And there's a lot of numbers that multiply to be 36. You got 1 times 36, 2 times 18, 3 times 12, 4 times 9, and there's also 6 times 6. But which one's going to add to give us negative 13? Well, ultimately in the end, it's going to end up being 4 and 9. But they do both have to be a negative number. 4 has to be negative and so does 9. So keep in mind that a negative times a negative is going to be a positive, and then these do add up to be negative 13 like we want. Okay, so how this one's going to factor, it would just be x minus 4, and then x minus 9 since they're both negative. And now solving them, set each one equal to 0. And now we just get the opposite answers of positive 4 and then positive 9. Just add 4, add 9 to both sides. There's your two answers. Okay, for number 9, same idea. So I want to find two numbers that multiply to be 10. Those same two numbers have to add to be 7. Shouldn't have to think too hard about this. 2 times 5, right? So 2 times 5 we all know is 10. Those do add to be 7. So setting this up, this would be x plus 2, x plus 5, both positive. So now solving them, set them both equal to 0. And you should get negative 2 and negative 5 as your two solutions. Okay, so again, hopefully this is kind of coming back to you a little bit. Should look familiar. Should be getting easier as we go along here. So look in number 10. Again, we want to find what two numbers multiply to be negative 33. And those same two numbers have to add to be negative 8. So there's 1 times 33, or there's 3 times 11. Obviously, it's going to be 3 and 11. That's going to add to be negative 8. But which one's going to be negative? So again, they're multiplying to be a negative. They're adding to be a negative. So if they're adding to be negative 8, you want the bigger number to be negative. So positive 3, but negative 11. So if that was a positive 8 instead, I'd want the bigger number to be a positive number. So it would be positive 11, but then negative 3. Okay, so how this factors would just be x plus 3, x minus 11. And now solving it, set them both equal to 0. Solving each one, you get x equals negative 3. And you also get that x equals positive 11. And there you go. So for number 11, so you don't have to make this table every single time. So, if it's coming back to you a little bit and you're really good at your times tables, you don't have to make this table, only if it helps you. But what multiplies to be 11 and adds to be 12 shouldn't be too difficult because 11 is prime, has to be 1 times 11. So 1 plus 11 is obviously going to be 12, so this would factor into x plus 1, x plus 11. And then solving it, we just get the opposite answers of negative 1 and negative 11 is our two solutions. And the last one, number 12, so we want to know what multiplies to be negative 15, and those same two numbers have to add to be negative 2. We all know 5 times 3, and 5 would be the negative number. So again, if they're adding to be a negative, the bigger number has to be negative, which would be 5 in this case. So this factors into x minus 5, x plus 3. Solving it, we get two answers, just the opposite. We get positive 5, and then negative 3 is our two solutions. All right, so again, I like to call those just basic trinomials. We're down at the bottom now. These are everybody's favorite. These are those guess and check ones. Okay, so what makes these so different from the last trinomials is that, well, now we have a 2x squared and we have a 4x squared. Whereas these last 6 problems, if you notice, this had a 1x squared, a 1x squared, a 1x squared, right? All 6 of these were just a 1x squared. Where now you have a different number in front besides a 1. Okay, so these are going to be factored a little differently. But here's how I kind of do guess and check. So it is going to be 2 sets of parentheses again. And to start it off, so if I'm talking about 2x squared, well, it's got to be a 2x and a 1x. Okay, that's the only way. If you remultiply these back together again, that's the only way that you get 2x squared, is 2x times 1x. Okay, the rest of these parentheses, so to fill out the rest of it, these last two numbers have to multiply to be negative 5. They don't have to add to be negative 3. They just simply have to multiply to be negative 5. So think about it. What multiplies to be negative 5? Well, 5 is a prime number. You got 1 times 5 or 5 times 1. But this is going to be the guessing part. Okay, we know it has to be 2x and 1x. But where does 1 go? Where does 5 go? And not only that, but it is a negative 5. So how do I get a negative number? Well, that means that one number has to be positive and one number has to be negative. So that also is going to be some guessing. Okay, so place your guess, whatever you want to do. Maybe you want to put 1 here and 5 here. Okay, so now play around with the signs as well. One's positive, one's negative. So I don't know, maybe this one's positive, this one's negative. Okay, so I place my guess and now I need to check it. How you check it once again is by foiling these two back together again. So if I re-multiply these, 2x and x, that's obviously going to be the 2x squared like I want. 2x times negative 5, that's negative 10x. 1 times x is positive 1x. 1 times negative 5 is negative 5. Okay, so let's check it out. 2x squared, 2x squared. Negative 5, negative 5. So what we really need to check right now is this middle portion. Negative 10x plus 1x, that's negative 9x. But we want negative 3x. So that's a no-go. Okay, my first guess was incorrect. I can't have that. That did not work out. So now I need to try something else. All right, so I think that was too big. Maybe what I want to try instead is put 5 here and put 1 here. Maybe I'll try that. Okay, I'm going to keep the signs where they're at, but now let's check this one and see where we're at so far. So 2x and x again is 2x squared. 2x times negative 1 is negative 2x. 5 times x is positive 5x. This would be negative 5. So again, we got the 2x squared, we got the negative 5 like we want. In the middle here, negative 2x plus 5x, that'd be positive 3x. But we want negative 3x. So we still don't have it. So what does that mean we have to do? One last and final thing. You just need to change your signs. Make that a negative 5, make that a positive 1. And then we should be all set. Okay, so if I check this one last time, I'm sure some of you are already kind of doing it in your head and you already know that's going to work. But just to double check, 2x and x is 2x squared. 2x and 1 is 2x. Negative 5 and x is negative 5x. Negative 5 and 1 is negative 5. So this right here in the middle, that's my negative 3x like I want it. Okay, so we're all checked out. We're all good. All right, so we got it to factor. Now we need to solve it. So I set 2x minus 5 equal to 0. I set x plus 1 equal to 0. So I'll get the easy answer first. That's negative 1. Adding 5 to both sides and then dividing by 2, you get 5 over 2 as your second solution. Okay, so I know it's not always the easiest, but as you can see, you know, if you don't get it right the first time, you just switch things around. Not a big deal. Okay? For the next one, number 14. What makes this one kind of more of a pain is the fact that it's a 4x squared. So why is that a pain? Because, well, you can have one of two things. 4x squared could be 4x and 1x, or it could be a 2x and a 2x, right? Because 4 is a composite number. It's not prime. There's two different ways you can get 4. You can get 4 times 1 or 2 times 2, right? So this would be a lot of playing around, figuring out numbers. So let's just try the 4x and the 1x to start. Let's try that one first. I'll get rid of this one for now. So we got 4x and 1x. Okay, so now what multiplies be negative 7? Well, that's 1 times 7 or 7 times 1. So playing around with these numbers. So if I just put 1 here and 7 here, I'm not even going to worry about the signs right now because I just want to show you guys, if you just do some mental math, just do some quick foiling in your head, you'd have 4x squared, you'd have 28x, and I'm just going to stop right there. Because following that 28x would just be a 1x and a 7. Well, this is going to be nowhere near the 12x like we want. 28x and a 1x, that's not going to work. So even if I switch it, let's try and switch it around now. Maybe if I put 7 over here with the 4 and put 1 over here, where are we at? So this would be 4x squared. We got 4x and 1x, that'd be 4x. 7 and x, so that's 7x. 7 times 1 gives me 7. Okay, so looking at these numbers now, 4 and 7, the closest I can get would be 11x. But again, I want to make this a 12x. So I'm just going to rule this out right now. It can't be 4x and 1x. I'm just going to rule that out. That's not working. So now I want to try 2x and 2x. So let's try the next option. We got 2x and 2x. Again, it has to be 1 and 7. So let's just say, I don't know, 7 here, 1 here. It doesn't really matter because they're both 2x. But now we got to play around with the signs as well. Okay? Or even if you wanted to just try and FOIL it right now, let's just try and FOIL it. We'll figure out the signs later. This gives me 4x squared. This gives me 2x, 14x, and then 7. Well, I want positive 12x. So how do I get positive 12x out of that? Well, I'd have to have a negative 2x and positive 14x, right? So how do I get negative 2x and positive 14? Which one's positive, which one's negative? Well, we did 2x and 2x times 1, so this would have to be negative 1 to make that negative 2x, and then positive 7 to make this positive 14x. And again, the 7 times negative 1 makes that negative 7 like we want. So even if you want to do the signs later, maybe you just want to play around with the numbers a little bit and try and see how close you can get to that actual number in the middle, okay, and then figure out the signs later. It's just all a guessing game. Okay, but the better you get, or the more you practice these, the better you will actually get, believe it or not. Again, you're going to be doing a lot of the math in your head eventually, and then you'll just be able to see it all unfold pretty quickly. Okay, but you've got to practice these types of problems. The better you practice them, the more you practice them, the better and better that you will actually get at these. Okay, so we got it all set. We got it factored, so now just set 2x plus 7, set that equal to 0. Set 2x minus 1 equal to 0. And then solving each one, if I subtract 7 and then divide by 2, you get negative 7 over 2. And then 2x minus 1, you want to add 1 to both sides and then divide by 2, so you get positive 1/2. All right, so there's your two solutions. All right, so there's guess and check. The last ones I want to go through with you guys. On the back side, these are called perfect square trinomials. Okay, so how do these work out? What are the characteristics to a perfect square trinomial? Here's how I know it's a perfect square trinomial. Okay, well, first of all, even just looking at 15 just as a normal trinomial, just a normal one that's a 1x squared, just think about for a second, what multiplies be 49 and adds be 14? Well, we all know 7 and 7, right? 7 times 7 is 49, 7 plus 7 is 14. So this would factor into an x plus 7, another x plus 7. And here's what happens every single time it's a perfect square trinomial. You get the same exact binomial twice. Okay, the same exact one, signs and everything. They're the exact same binomial. Where ultimately what's going to happen, you're just going to have one solution. So instead of getting two answers like we have for every other problem, you just get one answer, x equals negative 7. And what that would mean for this problem, if you were to actually graph out this parabola, so here's our x and y axis, this would mean, so it would be an upward facing parabola, it would just be touching the x-axis at the vertex of negative 7. So what that means again, it'd be an upward facing parabola. The vertex would just be touching at negative 7. That's what that would mean. So at x equals negative 7, it would just be touching right there, and then it'd just go back up the other side. Okay, but there's a lot of characteristics when it comes to being a perfect square trinomial. Let me kind of outline it for number 16. Okay, to know that for sure that this is an ultimate, or that this is a perfect square trinomial, the first term has to be a perfect square. So if you take the square root of that, it'll just be x. The last term has to be a perfect square. The square root of 36, that's 6. Okay, so there's more to it than just that though. So it's not just done at that. Okay, that's not the only case scenario that I know it's perfect square trinomial. Now what you'd want to do is you multiply these together. So I just make that 6x. And then when you double it, you should get that middle term, which would be 12x there in the middle. This is how you know that it's a perfect square trinomial. It's got to meet all these qualities, all these characteristics, in order to check it all off and to make sure that it's a perfect square trinomial. Okay? But the way that this one would factor then, it would factor into an x plus 6, followed by another x plus 6, the same binomial twice. Okay, so where does that come from? X, 6, plus sign comes from the middle. X plus 6, x plus 6. So from here, solving it, just set x plus 6 equal to 0, you get x equals negative 6. So again, just one answer in the end. Whereas 17, the next one, again, this is definitely a perfect square trinomial because the square root of x squared is x, the square root of 25 is 5. Multiply these together, that make that 5x. And if you double it, that is 10x there in the middle. Okay, but here's where that minus comes in. That minus 10x, here's where it comes in. When you factor this, it's going to factor into an x minus 5 and another x minus 5. Okay, again, the x comes from the first term, the 5 from the last term, minus sign from the middle. So this would just solve now into x equals positive 5. And that'd be it. Okay, so same thing for number 18. It's a perfect square trinomial because the first term, square root, that's 2x. Last term, square root, that's 5. multiply them, that's 10x. So 2x times 5 is 10. And if you double it, that's 20x there in the middle. So the way that this one's going to factor, it'd be 2x minus 5 and another 2x minus 5. Again, the same binomial twice. So now solving it, set 2x minus 5 equal to 0. Add 5, divide by 2. You're looking at 5 over 2 is your solution. All right, 19. Again, just to check it. First term, take the square root. Last term, that'd be 10. That'd be 10x when you multiply them, double it. That's 20x there in the middle. So check, check, and check. It all works out. All right, so the way this one would factor would be x plus 10, followed by another x plus 10. Solving it, set x plus 10 equal to 0. You get one answer of negative 10. And there's your solution. The last one, number 20. All right, you can kind of do this one of two ways to start. You could factor it as is. However, there is a GCF you could take out of all three terms before you even do anything else. Okay, you could take out a GCF. You look at these numbers, 36, 48, 16. The biggest number you could divide out is a 4. So if you take out a 4 from all three terms, you would have 9x squared minus 12x plus 4 left over, which is still actually going to be a perfect square trinomial. So check it out. That 9x squared minus 12x plus 4, the square root of 9x squared is 3x. Square root of 4 is 2. Multiply them, that's 6x. And again, when you double it, you get 12x there in the middle. So this thing fully factored would be, you got your GCF out front. You'd have 3x minus 2, another 3x minus 2. And now just solve it. So just set 3x minus 2 equal to 0. You get one solution in the end, add 2, divide by 3. You're looking at 2/3. Okay, so 2 over 3 is our final solution. But even if you didn't do that, even if you didn't take out the GCF from the very beginning, you still get to the same answer, but you just need to reduce it. So let me show you that real quick. So again, let me just copy down the problem down here. So it's 36x squared minus 48x plus 16 equals 0. So even if I didn't take out that GCF, right, if I just double check, square root of this is 6x, square root of this is 4. Multiply those, that's 24x. And then when you double it, it is 48x. But the way this would factor would be 6x minus 4, another 6x minus 4. Where when you solve it, if you set 6x minus 4 equal to 0, you would add 4 and then divide by 6. Where again, like I said, you just need to reduce your final answer, which still comes out the same to being 2/3. Okay? So hopefully this all rings a bell. Maybe you probably haven't seen too much of the perfect square trinomials before in the past, but everything else on this front side I know for sure you guys have done before. Okay, so your homework assignment is just simply 15 problems, and you only have to factor them. So read the directions fully. There is no equal 0. You are not solving them. So don't tell me that x is equal to whatever as your solution. Just simply factor, and that's it. Okay? So get some practice. Again, make sure you practice these. You need a strong foundation now. You need to understand factoring now. Otherwise, it's going to be a lot tougher later on. Okay, let me know if you have any questions on anything, but have a good day.